All right, lesson 10.8 is likely versus unlikely and making predictions. This starts on page 15. What you can see at the top of your page here is really a continuum for our probability. And probability can range anywhere from the 0% being completely impossible to the certainty point, which is going to be 100% chance of it happening. So if you think about even like predicting with the weather and stuff like that, we talk about having a percent chance of things happening. Unlikely is down here in this category, for example, a 1 in 6 chance. The even chance would be like flipping a coin, getting heads or tails, and this right here is a 50% chance of happening. Likely would be something like 4 in 5 chance, so that would be 4 out of 5 or an 80% chance. So this is one continuum that you can kind of take a look at to kind of help guide you. Another continuum is right here. So this is a pretty basic picture for you, and it shows you the probability both in decimals as well as percentages, which we could then change over to fractions if we wanted to. You can see down here still at the impossible category, this is very unlikely, up to about 20%. From 20% to 40%, we say this is an unlikely category. From 40 to 50, we have less likely than not. And then once we hit that 50 to 60%, we're more likely than not into the likely, very likely, and then all the way up to certainty here. So probability is on this continuum here, and it kind of allows us to choose like how likely, what are the chances of something actually happening for us, so that favorable outcome happening. A quick review for you, independent versus dependent. When we have independent events, we have 2 or more events. And that actually qualifies for both independent and dependent events. When you were talking about independent events, the one event does not affect the other. So when we can talk about this, it could be, for example, spinning a spinner and then flipping a coin, rolling a die and then flipping a coin, or rolling a die and spinning a spinner. Dependent events, the first event determines or affects the second. So for example, this was the one the other day with our suitcase example, where if we picked a shirt out of our suitcase, it was no longer in the suitcase. So number one, there were a different number of outcomes for you. And number two, you also potentially had fewer to actually choose from if you were actually trying to pick the same exact color. So real quickly, spinning a spinner and rolling a number cube here or a dice, these are going to be independent events because the spinner has nothing to do with the dice. Probability that we get a yellow, and then we also roll a 4. So out of this spinner, our yellow is 1 out of 5. And on our dice here, our 4 is 1 out of 6. So we go ahead and multiply, and we get 1 out of 30 for this probability then. All right, for our next example here, we have our twister spinner again, and we also have a coin. So if I spin the spinner, it doesn't necessarily mean that I'm going to get heads or tails or anything. So these are what we would call independent events. So the chances that I land the spinner and actually land on a foot, those would be 2 spots out of 4 if I'm looking into like the big 4 divisions here, because this would be a foot and this would be a foot. And the probability that I get heads is going to be 1 out of 2. So simplifying here, those both become 1s, and I get a 1/4 chance of that happening. Not very likely for that to happen. Without replacement, which means we're going to pick and then we're not going to put it back. So because we are not putting it back, obviously that is going to change our scenario pretty rapidly here. And taking a look, I have 2, 4, 6 plus 4, so that's 10 total here. So if I pick out a green marble, that's going to be 2 out of 10 on my first pick. When I go back in, because I'm keeping it, I'm going to be down to 9. And white marbles, there are only 2 of them. So I can reduce here. This is going to become 1/5, and that's going to give me 2 out of 45 then for my probability on this one. The other thing that we can do with probability is we can actually use theoretical or experimental probability to help us make predictions for the future. So fact, there are 6 red marbles out of 20. How many red marbles should be selected out of 100? So the first thing we do is look at the probability of 6 red marbles out of 20. And we can go ahead and actually reduce that. So 6 out of 20 is going to give me 3 out of 10. And then we can take this probability and we can use it to make a prediction. So to make our prediction, we're going to take our probability and we're going to multiply it by the bigger picture, which in our case is going to be a 100 here. So our prediction to be able to figure out a red marble is going to be 3 out of 10. And we're going to multiply that by 100 marbles that are actually in another bag. And multiplying that, we would anticipate there to be 30 red marbles then in that other bag. So we can use our probability to make a prediction. On this one, when asking 50 people their favorite type of pants, the results are shown on the right. How many people out of 200 would vote for capris? So it already told us that the total was 50 here. Capris is 15, so the probability of picking capris is 15 out of 50. Reducing that fraction, you get 3 out of 10. So we're going to take that probability, 3 out of 10, and we're going to multiply it by our bigger picture, which is going to be 200. And multiplying 3/10 times 200 is going to give us 60 people who would vote for capris, or that's our prediction out of 200. Survey found that 15% of people do not use emojis in their text messages. Predict how many of the 2,450 students at Washington Middle School use them. So if 15% of people do not use them, we can say 100% is everybody. Take out the people who do not use them, we have 85% who actually do. So the probability that we have an emoji is 85%, or because we're going to put this into our calculator, we can go ahead and change it to a decimal version, or you could even put it as a fraction. Take your prediction then, which is 0.85, and we're going to multiply this by the entire student population of 2,450. So multiplying that, we get 2,082.5. So we have to say we're looking at whole numbers here. So we have 2,082 people who actually would use emojis then. And that is it for your lesson.